Hello, everyone. Welcome again to our talk about the AI engineering book. Um, we're gonna talk today about the chapter 7, fine tuning. So, basically, let's start by defining this concept. So, basically, fine tuning is like updating the model weights for unspecialized task. So, you know, wanted to customize for your domain, and you don't actually uh, get a good outcome by just prompting, neither using RAG. So we just need to actually fine tune the model. There's basically two main fine tuning approaches described in the book. The first is supervised fine tuning, which you will have like an input output pairs. An input could be an instruction, and the output could be the response, and that will be fed to the fine tuning processes. And we also have like long context fine tuning, which is basically changing the architecture of the model to deal with longer context length. So this is harder to implement because it requires changing uh, some positioning embeddings in the transform. So it's not like super um, like it's more advanced techniques. Um, but yeah, basically the core idea here is to go from a general purpose model and make it more specialized for your use case. But as well, that there's trade-offs as any decision in software engineering, and here is not an exception. So there are some many cases that we don't need to actually fine tune your model, because some of the risk is performance degradation. So fine tuning for specific tests could degrade for other types of tests. There are some infrastructure requirements, so we need to define the training parameters for these fine tuning um, routine. You need to monitor the process. You need to debug if anything is going wrong. You need to host this new fine-tuned model, because you know you're not like be just calling an API for an external provider. You need to actually call your model fine-tuning. So that's are basically the main things, drawbacks of going to this approach. And comparing with the technique that we talked previously, the RAG, we have some difference, and the book explored this difference very well. And to summarize, they basically mentioned that RAG is more um, focused on factual things, informational things, problems, and fine tuning is more related to behavior or format problem. I don't actually agree 100%, but I agree on the concept of the idea of this distinction. But basically, this is the main the direction of the book follows, to differentiate, and they are not mutually exclusive. So, for example, you can start using RAG um, to solve some factual consistency problems, and then combine with fine tuning to make it more um, fill some gaps of the domain knowledge that you're not being able to solve even with the factual information fed to by the RAG, or even some more complex formats that not being structured. So taking I step back and talk more about the staged approach of using these techniques in your AI application. So the recommendation is start with prompt engineering. Start with basically an OpenAI, for example, an OpenAI call and a prompt, and refine these. Add a set of example 1 to 50, for example, and connect with other internal data source to fill the gaps of this factual consistency information that the model itself will not have, even date related things, because these models have a cut-off date of the training, and then go for more advanced techniques, and then fine-tuning go it starts here. So for information failures, you need to add more advanced RAG techniques. For behavior issues, you need to fine tune for specific use cases, and then combine these two because they, as I mentioned, is not they are not like mutually exclusive. Um, Going to the a more common way to implement this fine tuning, there's a technique called parameter efficient fine tuning, which is basically, as to state in a very marketing way, it's like a, instead of training harder, you need to train smarter. So basically, is a way to perform the fine tuning with the fewer trainable parameters, which makes faster and more easy, with less latency, and easy to manage, instead of the previous fine tuning techniques. So the core idea, is to, instead of updating all the model parameters, you need to only update a small subset. And it was proposed in 2019 for a problem related to the memory bottleneck uh, of the large language models. And basically, how it works is basically introducing an adapter based um, layers in the architecture. So all the other layers are freezed, and we only update these adapter based layers in the fine tune, and we insert new parameters in the right place during the fine tuning, instead of updating all of them every time. So this consequently leads to less trainable parameters. And the key benefits are that we drastically remove the memory requirements to fine tune a model. We have faster training, as I mentioned, and also easy to deploy for this fine tuned model. So we have like lightweighted. It will be like a lightweight model, and compared to the previous versions. And but we consequently will increase a little bit the latency because of these new layers compared to the a non fine-tuned model. But this is like an expected drawback because is inherent of the fine-tuning as a whole. The author also talks in this chapter about some other techniques called like model merging, but I will not go deep here because I don't think they're super useful in a day-to-day work, but it's very interesting for thinking on advanced techniques to improve. So basically, if you have like multiple models, you can combine, similar to what we do in the ensemble in the traditional machine learning, but is instead of combining the model outputs, we combine the model weights, and we merged it, so we can have like um, a fine-tuning representation, so we can work with and have more, expecting to have more better results of this representation to the actual model response. Finally, talking about fine-tuning frameworks and tools. So basically, the most common is the key providers, OpenAI, Anthropic. They have in the APIs a way to, even like visually, they have like UIs to perform quick and easy the upload of your data that you want to fine tune, and then routines to fine tune and output this for you to roast or to use as inference. We also have other like third party frameworks like Llama Factory, PAFT, that you can work with, but it needs to more technical expertise on this, and also a lot of other like GitHub pages, GitHub repositories that you can take a look on how to that perform this fine tuning process in a more like transparent way, so you can be more in control of what is happening. So basically, for the adapter based fine tuning, you will need to regarding the compute requirements you can use in like a mid-tier GPUs. But for the full fine tune, you it will require to use like some cloud and distribute training platform, because it's like heavier. So you need to go for deep speed, PyTorch distributed, Colossal AI, so we can have like more better results. And even like need given the compute requirement, you will not be able to run in your local machine even with the a larger GPU. So basically that's it for now. We I think we were able to talk a little bit about the fine tuning in this chapter, and it's a very interesting technique for improve the AI agent performance, the application performance. And you just need to understand when and when not to use, because as I mentioned, there's many drawbacks in this technique. You just need to understand when it is suitable to use or not. uh, I think that's it. See you in the next section, in the next talk that we're gonna talk about the chapter 8, dataset engineering. Bye bye.